So moving on with our second aquaculture intern. So next is going to be Jessica talking about her project. She is a rising senior at UMBC, and we were really happy to have her over the summer. She did a lot of great work. So yeah.
So hi everyone, my name is Jessica Baniak, and as Brittany said, I'm going to be a rising senior at UMBC this year. And my project, well, my first project is going to be on the peaceful sleep, more efficient ways to sedate oysters for sampling. So for anyone that doesn't know, anesthesia is the temporary loss of sensation that can cause relief from pain, muscle relaxation, and/or unconsciousness. So the picture on your left is an oyster that is anesthetized. And so it's a little bit open compared to the tight knitting that you normally see. So for oysters, it was found that magnesium chloride has been proven to be one of the most effective chemicals for oyster anesthesia with the lowest mortality. So some benefits of oyster anesthesia is that usually to get samples from oysters, you would have to shut them, which in the process kills them. Which means, yes, you will get data from that particular oyster, but you cannot work with that oyster from that point on. So that kind of defeats the purpose if you want to do certain things like sex determination, tissue biopsy, and physiological and genetic studies. So this anesthesia allows you a way to continue work with these oysters from then on. And it's also helpful for the pearl industry that it simplifies surgical techniques used in pearl production and extraction. So the reason that we're focusing on this study is that the chemical that we use, magnesium chloride, is pretty expensive. So the paper that I based my study off of, Sequet et al. 2009, found that the ideal concentration of magnesium chloride for optimal anesthesia was 50 grams per liter over a 16-hour duration. The magnesium chloride, the bottle that you see on your left, that costs $61.20. And at this concentration, every liter of water we would use to anesthetize the oysters in would cost $3.06. So if our setup that I'm about to show, if we had used that concentration for all three, it would cost close to $300, which isn't practical if you're trying to sample a lot of oysters overall. And furthermore, at high concentrations, magnesium chloride is harder to dissolve and creates health risks due to excess heat and irritation of the respiratory tract. So our objective was to create a more efficient, effective method of utilizing magnesium chloride to knock out oysters in a cheaper, faster, and safer way. So here is the actual setup that I used for a couple of the trials. As you can see, there are 3 tanks that each hold 30 liters each, and in them we have 30 oysters, and we would change the concentration of these tanks throughout. So the general procedure of this project would be that we place all the oysters in the tank, and every hour we would check the amount that were anesthetized and we would remove them. We would place a nail to prop them open so we could take a mantle sample. It's a little bit hard to see, but around here, that is the mantle, and there's a little portion of it that has been removed by me. So what I'm doing in this image right here is actually taking a knife and removing part of the sample. Because in normal laboratory experiments, they would be using this for sampling. So we wanted to see their mortality rate with normal practices of the lab. So we were trying to replicate these results. So after we removed the sample, we would weigh the oyster and measure its height because we wanted to see if certain sizes were anesthetized faster or slower than others. And then finally, we would put them in a tank to recover, and after a couple of days, record the recovery rate of the oysters in this experiment. So we ran 4 trials overall. So the first trial, our main thing we were trying to focus on was that a pump. If a pump that filters the water, could we lower the concentration of magnesium chloride and create a more effective way at anesthetizing the oysters. So our first trial was to have the 3 tanks in that setup you saw before at 5 grams per liter. So we were trying 10% and trying to get as low as possible to see what we could achieve with the pump. Our second trial was starving the oysters with the same conditions from the first one to see if starving them would create a higher percentage of anesthesia. So starving them increases the filtration rate. So this might allow more uptake of the chemical, which might anesthetize them more. Trial 3 was our control based off the paper that I mentioned earlier of that 50 grams per liter in the tank. So yes, the 50 grams per liter. And trial 4 was putting a pump in the 50 grams per liter. And I'll explain why I did that later. So for our results, here are the 4 trials, and the paper is the one on your right. So these are the amounts that we should be comparing to and seeing. So this is the 50 grams per liter and the high concentration. Trial 1, as you can see, 3 hours here, it was at around 65% compared to the 80% of the trial, which is not a lot lower compared to having 10% of the magnesium chloride. And trial 2 with starving almost got it up to that 80% that was in trial 3. And both trial 1 and 2 caused 100% of oysters to be anesthetized after that 24 hours. So both of those, I think, were a success and look very promising. However, where the experiment went a little bit off was trial 3 should have been the control. So it should have the exact same results as the paper, but this did not happen in our case. And so trial 4, I tried to put a pump to see if that made a difference. And yes, there were more oysters that were anesthetized. However, in the next chart, the recovery percentage of the oysters, so the ones that actually lived after a couple of days, trial 4 had none that survived. So yes, it might have opened with the pump, but that might have just meant they died in the process. So trial 3, there was a little bit recovered, but not nearly that 100% that we should have been seeing in the other trials. So what we think, so it's kind of hard to see, but this water should be clear. This is what the 50 grams per liter concentration is, and the water should be clear. So we think that our problem of mixing the 50 grams per liter into the water, we could have done different things in actually mixing it. So some potential fixes that people recommended was to pour the water into the magnesium chloride and mix it throughout or heat it. There were many different things we could have done to try to fix this problem for a later study. So our final thing was the weight and height. We found an overall trend of the larger the oysters were, the faster it actually took them to be anesthetized. So the stars are the ones that were significantly different. While they're not on everything, there still is a general trend of from that 0 to 3 hours to the 3 to 24 hours that after they were anesthetized, it did decrease in the height and weight. So some conclusions of the best protocol to use was definitely adding a pump made a difference, that even at 10% of the concentration, they still had results that were very similar to the 50 grams per liter. I would much rather spend $30 instead of $300. So I think this is worth exploring more. And also starving the oysters from trial 1 to 2, this did create an increase where it almost matched the paper's results completely. So some further steps that we could do is to repeat the experiment at a lower volume of water. We could increase the concentration of the magnesium chloride in intervals to find the lowest amount we can go or find the optimal amount that we want. We can test the type of pump or filtration system, and we can do more trials related to starving. We could also determine the ideal number of water volume to minimize the excess water use and just really make this a very good protocol to use from now on. So here are my citations. And here are the people I would like to thank. Thank you, Dr. Liu, Brittany Wolf-Bryant, who Lee's also there, and all my fellow interns, and Dr. Amanda Knobloch for all your help, and all the oysters that I killed when I didn't mean to. I'm sorry. Do you have any questions?
Yes, I have a question. How do you know when the oyster is anesthetized? How can you tell?
How do I know when the oyster is anesthetized? Is that correct?
That's correct.
Okay, so it doesn't work. So that the muscle relaxation actually opens the oyster a little bit. Like usually when you take it out of the water, they're closed very shut and you have to shut them to open them. But when they were a little bit open, that you could actually get things in and I could take samples from them. Okay.
We have a question from Zoom. Upon seeing that trial 3 didn't correspond with the paper's findings, did you see if any other researchers had similar problems? Had anyone else in the field struggled to replicate the original trial's results?
That is definitely, we ran out of time currently, but I could definitely go into that more later on. And if I wanted to run this trial and find the best results.
So really nice presentation and well given. I apologize, I missed the first couple minutes, but I made this. Was trial 3 run at the same time as trials 1 and 2? Were they simultaneous?
So that was actually a good point. We wanted to save as much magnesium chloride as we could. So trial 1 and 2, all 3 of the tanks were running at the same time. And so trial 1 happened on one day, trial 2 happened the next day. Trial 3, we used one container, one of the tanks, because we didn't want to do all 3 at that 50 grams per liter to save some money. And so we ran those over 2 days. So we did 2 replicates for that. And for trial 4, we did 2 replicates for that.
So could there be any factors doing them in that order that could have caused the problem?
Absolutely.
Yeah.
That there's always variability when you're doing things and if it's not all the same. So some of the factors were at sometimes the oysters might have been kept out longer than possible because we did get a second batch of oysters later on in the week because we decided to run more trials on it. So they're different oysters, there's different timing to it. And we don't know if the conditions in the pier where we took them out might have been different. So there's a lot of things up.
Thank you.
Hi, can you hear me? I don't know if I can ask a question out loud on Zoom. No, I can't.
Someone says something.
Yeah.
Anybody on Zoom have a question?
I was going to try to ask a question out loud, but I don't know if you can hear me well enough.
Yes, we can.
Okay, I was just wondering if you had a proposal or an idea of why the larger oysters were nested faster than the smaller oysters.
So that is actually one of the most interesting parts of this study. In the paper that we were reading, we found that a higher percentage of the smaller oysters were actually anesthetized compared to the larger. So this does somewhat contradict the paper. So there's definitely more research in that. And that was something we did not plan to see at all. So that could also require further research.